All right, everybody, today we're starting our ultimate review for the week. We're going to be doing a lot of different chapters. Right now we're trying to find the probability of hitting inside of the circle just the shaded area. All right, so we're going to find the shaded area, we're going to divide it by the total area, then multiply it by 100%. So right now, the easiest thing to find is the total area, which is the area of a circle, which is pi r squared. So if you look carefully, our radius is 6. So our area is 36 pi units squared. That right there is the total area. Okay? The next thing we have to figure out is how in the world can we find the shaded area? Now this is the area that's considered to be shaded right here. That's the shaded area. That's what we're going to try to find. Now, the only thing that was given to us was the radius here is a 6, which means this radius also has to be a 6. And we have this triangle right in here. Now that's 120 degrees. Now if you think about it, 120 degrees out of 360 degrees means we have a third. The whole thing, when I say the whole thing, I'm talking about this whole section right here. How much area is that whole section right there? That's a third of the entire circle. All right? We're just trying to find what? Not a third of it, we're trying to find this portion. So what we're going to have to do in order to find this shaded area, we're going to have to take a third of the circle. We're going to have to take a third of the circle, and we're going to have to take away the area of one triangle. And if we can find the area of a third of a circle and take away the area of one triangle, what is that going to give us? That is going to give us the area of the shaded region. All right, so we have a third of the circle. Well, if the whole circle is 36 pi, what would be a third of 36 pi? 12 pi. Now, everybody, if you're wondering why am I using 12 pi units squared, well, let me put it this way. 12 pi is a lot easier to write than all that junk. All right? That's the approximate value. That's the exact value. Okay? We go back. Now, what do we have to find now? We have to find the area of a triangle, right? 1/2 the base times the height. That's what we got to find. The base times the height. Well, let's see if we can find the base and the height. If I call this segment the base, if I said that's the base of the triangle, what does the height always have to form with the base? What kind of angle? A right angle, right? So watch. From right here, I'm going to make this perpendicular. Now, what I've done right here, all right, is I've cut this perfectly in two. All right? Yes. Yes, this right here, if you watch carefully, this half right here, what's that triangle? That's a 30, 60, 90. So right now I'm going to write 30, 60, 90, x radical 3, and a 2x. So let's take a look at this. If you look at this triangle, does everybody see how the 6 is directly across from the 90? So I'll put 6 right here. All right? Now, this angle right in here, everybody, this angle right in here, that's the 60-degree angle. You know what? It's kind of hard to see. So you know what? That 120 was cut in half. Put a little arrow here. That's 60 degrees right in there. Okay? Now, what's this segment right here? That segment. That's across from the what? The 30. So what does that have to be? 3. So put a 3. Okay? And you got it. 3 radical 3. So what does that mean? That means this is 3 radical 3. What does this mean? That's 3 radical 3. So if I wanted to take this information, okay, no, slow down. Let me do the setting up here, okay? Now, the height of this triangle is 3. So we'll put a 3 right here. Oh, sorry, wrong place. Now the base of the triangle is 3 radical 3 and another 3 radical 3, which makes a total of 6 radical 3. Because when you add 3 radical 3 plus 3 radical 3, it's a total of 6 radical 3. All right, so right now, half of 6 is 3. So 3 radical 3 times another 3 becomes a 9 radical 3 units. It's not working. Sorry. Units squared. There we go. So the area of our triangle is 9 radical 3 units squared. The area of our third of our circle is 12 pi units squared. Now the whole purpose of this, why are we finding both of them? We're trying to find the area of the shaded region. So we're going to find the area of the whole thing and take away the triangle, which leaves us just the green area. So in your calculator, go ahead and work on it with me. Here we go. We have 12 pi. What are we going to take away? We're going to take away 9 radical 3. Oh, hold on. I'll go. Let me go back. 1 second. Let me go back. Okay. The whole thing is 12 pi. Now, I did half of 6 and got 3 radical 3, and then took 3 radical 3 times 3, which gets me 9 radical. Forgot that. Okay. All right. It's okay. Now let's go back to our calculator. We're going to do 12 pi. Okay. Minus 9 radical 3, which gives us 22.11 units squared. Now, what does that represent? That represents the area of the shaded. We'll put right here, put 22.11. All right? It's okay. But what's the total area? 36 pi, right? So what are we going to do? We're going to take that, and we're going to divide this answer by what? 36 pi. Now, when you do this, it's pretty important that you put this in parentheses, okay? We're dividing it by 36 pi. And what do you get? 0.1955. You take that, you multiply it by 100 to get your percentage, which is 19.55%. Okay? So that's your approximate probability of hitting the shaded region. You have, when you take this and you divide it by this area, this is the total area. What does this represent? That represents the shaded area. When you take the shaded area and divide it by the total area, you get 19.55%. That's the chance of you hitting this area right here out of the total possible outcomes. That's what probability is. Almost 20%. Okay. Now, our next problem is going to be really, 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 really easy. Okay. Once again, what do you have to find? You have to find the probability of hitting the shaded area out of the what?
The total.
Shaded area out of the total area. How do we find the total area? It's the total area of a circle. There we go. Pi. Now, this is going to be a lot easier. I'm going to show you guys there are certain times where you can actually take a shortcut. This is one of those that you can actually take a shortcut. But we're going to go ahead and just do it the long way so you guys can understand why the shortcut works. Okay? Now, if this is 120 degrees, that means this has to be 60 degrees. And this also has to be 60 degrees. Because that's 120 degrees. By the way, this right here, everybody, in green, this is called a sector of the circle. Okay, that's a sector. All right, it's a portion of a circle. The formula that you could always use to find the area of a sector of a circle would be pi r squared degree that you have out of 360. That's how you can find the area of just one sector. Now, how many sectors do we have? We have a couple of them, don't we? So how many total degrees do we have? 120, right? Now, if you think about it, if this area is pi r squared times 120 over 360, and this area is just pi r squared, what's going to cancel out? This pi r squared will cancel out this pi r squared, and what are you simply left with? 120 out of 360. That's it. So our final answer for this one, you don't even have to do a whole bunch of... Now, even if you did, listen, you did pi times 5 squared out of what? 120 out of 360. What cancels out? This cancels out this, and what are you left with? Just the 120 out of 360. And what does this fraction reduce to? It reduces to 1/3, which the decimal equivalent is 0.333, goes on forever. So you would say 33.33% for rounding it to the nearest 100. So that would be your chance of hitting this shaded area out of the total area. Yeah,
just there's two 120s.
That's right. So why is this one easy? Because there's no shapes. And so if I wanted to make it more difficult, what could I do to make this more difficult? I could say, you know what? I'm going to cut there. I'm going to cut that. And just use this shaded area and that shaded area. And like you have to take the area of the sector and minus the area of the triangle. So you have to find the area of two equilateral triangles and do it. Okay? So you can make it harder, but I just decided not to. This one requires a much higher level of thinking. So in this one, we need to find the area of the shaded region. Now, the area of the shaded region is just this piece right here and this piece right here. Now, the total area is, once again, the area of the circle. So what formula we can use for area of the circle? Pi times the radius squared. By the way, if you want to right here, you could label this section R. Do we know the length of the radius? Nope. Length of the radius is not 4. 8. Nope. 6. No, it's not 6. Thank you for guessing and not listening. So right now, this 4 over here represents the apothem of the regular polygon. That 4 represents the apothem. From here to there. So now I'm going to be doing 3 different pieces right here, okay? Focus on the 3 different pieces. We need to find the radius for the total area. Okay? We need to find this side so that we can find the perimeter of the whole pentagon, which we need. Okay?
We need the area.
Now, the area of the shaded, here's what you would have to do to find the area of the shaded. Okay? What you're going to do is this. I'm going to map it out. You're going to take the area of the circle. You're going to take away the area of the pentagon. And then whatever answer that you get when you take the area of the circle minus the area of the pentagon. The area of the circle is what? Pi times the radius squared. The area of the pentagon is 1/2 the apothem times the perimeter. So those are the formulas you're going to use. Now, you only need how many pieces? You need 2 out of a total of 5 pieces. Does everybody see that you have 1, 2, 3, 4, 5 pieces? So whatever answer you get, you have to multiply that answer by 2/5. And then whatever you do, you take that and divide it by the total area, which is pi r squared. So go ahead and write this process down. This is your blueprint. This is your map of what you're attempting to find. All right, so the very first thing we're going to do, everybody, the first thing we're going to do is we are going to find the area of the Pentagon, which is 1/2 the apothem times the perimeter. That's the very first thing that we're going to do. All right? So if I were to write it down, I'd say 1/2. The apothem, and our apothem in this particular case is a 4. And now what's the only thing I need to find? I need to find the perimeter. That's what I'm looking for. So I got to find P. And P is going to be this, plus this, plus this, plus this, plus whatever this side is. Okay? So right now, this triangle is the most important triangle that we have. Now, if you remember the video with Dr. Evil, all right, he was able to cut the Pentagon into how many equal parts? 5, right? 5 equal parts. Now, when you take a circle and you divide it by 5, that gives you 72 degrees. But if you take half of that, which is right here, what is that angle going to be right in there? It's going to be 36 degrees. We're going to need that. Okay? So I'm going to make a bigger triangle so you guys can see it a little bit better. Make a little bit larger triangle right there. There's 36 degrees. I'm going to call this A. I'm going to call this R. And I'm going to call this side right here, for us, I'm going to call that side just X. I'm going to call it length X. Now our A value is easy. It was already given to us. It's a 4. So what do I need to find? I need to find R and I need to find X. So this is where we're going to use our trig ratios, okay? So I'm going to put a little arrow across. That means X is my opposite side. This happens to be my adjacent side, and R represents my hypotenuse. So, if I wanted to solve for X, this is what I would do. That's my opposite, this is my adjacent. So here's how I would write it. The tangent of 36 degrees equals my opposite side, which is X, over my adjacent side, which is a 4. Now, why? Remember, something you're going to need to know for your final is what? So, scintilla. And this time, what did we use? We used tangent. So when we cross multiply this right here, what are we going to get? We're going to get our value for X. So what is X going to equal? 4 times the tangent of 36 degrees. That's going to be important. Yep, just type it in. Here we go. 4 tangent 36. See that answer right there? Type it in your calculator. Make sure you have it because you're going to need it later.
I'm not doing that.
Multiply that answer by 2. Now, why am I multiplying this answer by 2? Let's look at the picture. Okay? I'll tell you why I'm multiplying it by 2. This distance right here is X. This distance right here is X. So what is that whole distance all the way across? A total of 2 X's. Now, how many of these lengths do I have? I have 1, 2, 3, 4, 5. I have 5 total lengths. So what am I going to do with that? I'm going to multiply that answer by 5. And what is that 29.06? What does that represent in our problem? No, that represents the perimeter of your pentagon. So put 29.06. Yeah, 29.06 right there. Right now, what I want you to do in the calculator is multiply 1/2 times 4 times that 29.06. 1/2 times 4, which is 2, times what? The whole enchilada right there. What does that represent? That's the area of the pentagon. So I'm going to cut that off right there. 58.12.
You can do this in your head. You'd be a genius. Then you could probably solve that.
Yeah. Okay, so what am I doing right now, everybody? I'm kind of filling in my formula right here. What did we just find the area of right here? That's the area of the Pentagon, okay? That's the area of the Pentagon. So that part's now totally done. That part's done. Now let's go back and figure out what else we need to find. No, we need to find the area of the circle. What do we got to find first? We got to find the R value. We got to find the R value. Okay? So everybody, this is the hypotenuse. This is the adjacent side. Which trig ratio uses adjacent and hypotenuse? Adjacent and hypotenuse. Cosine. It's right here for R, everybody. I'm going to show you how to find R right here. Okay? You're going to write the cosine of 36 degrees equals your adjacent side, which is 4, over your value for R. Now this proportion is a more difficult proportion to solve for, because when you cross multiply, you get 4 equals R times the cosine of 36 degrees. To solve for R, what do we have to divide both sides by? 4. No, the cosine of 36 degrees. And what will that give us? That will give us, this right here will give us our value for our radius. Remember, this is our radius. So I'm going to go to the calculator. I'm going to type in 4 divided by the cosine of 36. This is our approximate value for our radius. So now I'm going to go second pi times the radius squared. Now that's the length of our radius. What am I going to do with my answer? I'm going to square it. What is that approximately the value? The area of the what?
Oh,
Pi times the radius squared. What am I trying to find? The area of a circle. This is the area of the circle. So write 76 point, basically 80. You can use it. All right? So right here, what's the approximate value for our circle? 76.8? Which means right here you could put 76.8 or put 76.8. And now I have enough information to find my percentage. Okay? What does this right here represent? That represents the area of the circle. Okay? And what was our radius approximately equal to? Our R value was approximately equal to like 4.94 something. Okay? So now we're going to type all this in. Here we go. I'm going to do 2 divided by 5. Parentheses. I'm going to grab the area of the circle. I'm going to take away the area of my Pentagon. There's the area of my Pentagon. I'm going to press enter. That's 7.47. Okay? Now what am I going to take 7.47 and divide it by? 76.8. So we have 7.47 divided by 76.8. Divided by, go up here, grab the area of my circle, press enter again. What do I get? About what? 9.7%. If I take that answer and multiply it, multiply it by what? 100. And 9.72. I'm sorry, 73. Your final answer for this problem is, everybody, 9.73% chance of hitting here or here. Y'all have a great day.